Oh, wow.
All right, here we go. Mr. Durr, 5. Oh, that's not a 4 sine to the 4th x minus 4 sine x minus 1 equals 0. Yes, sir, Bob. What are we going to do?
We just straight up do a quadratic.
I straight up can do a quadratic, right?
Sine squared.
Oh, what did I do there? Oh, my pen got really not goodly. That's a squared. Thank you. Oof. So, A looks like quadratic, doesn't it? I got no double angles, nothing to worry about. So, yeah, let's do some good algebra on it, right? So, I'm going to go whoop, 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 equals 0. What's going to go in little boxes instead of x's? Sine x's, yeah. Sine x.
And then what factors of 4 mean?
4 times negative 1 is not 4.
What factors of, wait, that's a plus.
Yeah. It's a plus?
Yeah.
Ooh, it is a plus. Thank you. So what factors of 4 give you negative 4? Good job. What do you got?
Negative 1 and 4.
Nope.
Wait, negative 2 and negative 2.
Negative 2 and negative 2. So I'm now going to go, do these two give me 4 sine squared?
No.
No, what do I have to do?
Put a 2 and some.
Put a 2 and a 2. Now, you are looking ahead. If you put a 4 and a 1, you try a 4, and you go, I can't make a 4. You have to go back and make them 2 and 2, if that happened to you. Okay, 2 times what gives you negative 2? Love it. 2 times what gives me negative 2? I love it. So far, so good. Noticing these are the same, I'm probably not going to do the problem twice, but I could do it if I want to. Nothing's stopping me. Set each of factors equals 0. I should have asked you what to do next. Set the factors equals 0. Are you with me? Q, you good on that? Okay. All right, now what? Add 1 to both sides.
I mean, divide by 2.
Divide by 2 because it's multiplied.
I said divide in my head.
Good call. Okay, where does sine give you 1/2?
I remember. 60 degrees. Oh, wait, this is
sine.
Oh, that must have to be. Oh, the sheet is 30 degrees.
You said something interesting. I'm going to go ahead and write 30 degrees, but I'm going to pause there. We get so far?
Yeah.
Okay. Now, is it the only place?
No.
Okay, let me back up. If I solve this, I get the same one. Is that okay? It's the same thing. Okay, so 30 degrees. Now, that's not the right answer. Why is it not the right answer? Read back in your instructions. What does the instruction say I should do? It needs to be in radians between 0 and 2 pi, right? So I need all of them that are between 0 and 2 pi. Okay? So are you a degrees guy or radian guy?
Degrees.
You like degrees. So first of all, we got to find our second one because it's almost always going to be 2.
Which is
150 degrees. How did you get 150 degrees?
The reference angle is 30.
We know the reference angle is 30 because we just solved for what the reference angle is. It's going to be 30 degrees. We know sine's positive in the second quadrant because all sticky tangerine cores. So therefore, this is going to be 150 degrees, right? All right. Now, we can't have them in degrees. We have to change them to radians. So how would you, why do I know I have to change it to radians?
Because the instructions tell us to do that.
Instructions say between 0 and 2 pi. That means I got to do radians, right? So I'm going to do, what's 30 degrees in radian land? Pi over 6. And what's 150 degrees in radian land? Okay, so we got a couple options. We can either just straight up make the translation, or you can recognize that that means the reference angle is actually pi over 6, and this is pi. So I could do pi minus pi over 6, which would give me 5 pi over 6. Or I could go pi over 6, where 360 degrees is equal to 2 pi. Oh, wait, no, I'm doing that wrong. Completely doing that wrong. 5, no, this is not going to work today. Hello. Got too many buttons on. It's going to freak out. It's going to explode. Look out. Stand back. Never use the regular razor. That would be good. Okay, so I assumed that you knew what the answer was. That's not really fair. So 150, right? So I go 150 degrees. where 360 degrees is 2 pi, right? So I multiply across, I get 300 pi over 360 degrees, right? Degrees cancel out.
Simplify.
Then simplify, I get 30 over 36 pi, which is 5 over 6 pi. Should be the other one. Okay, so that's the other way you could do it. I don't care which way. Both of those are fun. Whichever way makes you happy, floats your boat, sinks your sinker. All right.
Change the cosine to x.
All right, so I look up the identity. It's written on there. It's cosine squared x minus sine squared x minus 5 cosine x equals 1. What's next, sir?
Then I distributed.
The 3. You're doing good algebra, which is what I would recommend. This is not strictly speaking the way you have to do for the next part, but you're more than welcome to do it.
Oh.
You don't have to do it this way.
Change sine squared x.
You got a sine squared and everything else is cosine? Absolutely. I got 3 cosine squared x minus 3 parentheses 1 minus cosine squared x minus 5 cosine x equals 1. Doing a beautiful job, man.
Distribute the 3.
Distribute the 3 through. 3 cosine squared x minus 3 plus 3 cosine squared x minus 5 cosine x equals 1.
And then I combine the like terms.
Combine the like terms. I got a cosine squared and a cosine squared. That's going to give me 6 cosine squared x's minus 5 cosine x. You're going to combine these over here or over there?
To the left.
To the left. So that's going to be minus 4. All right. Love it. Beautiful so far. This is artwork.
Quadratic.
Quadratic formula. So it's a quadratic. So I'm going to go 6 times 4 is negative 24. Factors negative 24 give me negative 5.
Not sure.
If we're stumped, we start. We go 1 and 24. One of those has to be negative. Is that going to give me a 5? Negative 5. No. Let's try 2 and 12 then.
No.
No. How about 3 and 8?
Yes.
Yes. Which one has to be negative to make a negative 5? 8. So that's going to be their factors right there. So now I'm going to start here. I'm going to go boop, cosine x, boop, cosine x, whoops, equals 0. Now these two have to give me 6 cosine squared, do they?
No.
Then what do we have to do?
Do you put 3s?
3 and 2, right? Because I'm
3.
multiplying.
Yeah.
So 3 and 2. 3 times what gives me 3?
1.
1. 2 times what gives me negative 8?
Negative 4.
Negative 4.
And set those equal to 0 now.
Set them each equals 0. Look at this. Yeah.
And then move. Okay, we'll start with the first one. So move the 4 over.
Move the 4 over. At 3 cosine x equals 4.
And then divide by 3.
Divide by 3. Cosine x equals 4/3.
And then for the other one, we move the 1 over.
2 cosine x equals negative 1.
Divide out the 2.
Cosine x equals negative 1/2. All right, what values of x give us 4/3?
Wait. What?
What values of x for cosine give us 4/3?
I'm not. How would I figure that out?
Miss Faulkner, do you remember? He wants to know what values of x give me 4/3 for cosine. Why nothing? Sorry, what? It's not a thing. It's not on your charts. It makes you suspicious. But it's more important than that. Mr. Alonzo, what's the highest value of cosine I can get?
Of cosine?
Yeah. It's the highest I can get on my cosine curve.
1.
1. What's the lowest I can get?
Oh, that's
Bigger than 1, right? So that's a no.
So not a right answer.
Not a right answer. What about this one? Where cosine equals negative 1/2? What values of x give me negative 1/2?
Values of x equal negative 1/2.
Mm-hmm.
So when cosine is a 30 degrees.
30 degrees. Okay, I'll buy that. But it's also going to be true in the what quadrant?
It's cosine, so fourth.
Fourth is positive for cosine.
Oh,
I need negatives.
So anywhere but the first and the fourth.
Yeah, so not there. So here and here is where it's going to be true. So this is going to be 30 degrees, and this is going to be 30 degrees as well.
So 150.
So 150. So I like that. 150 degrees.
And 210.
210. Love it. 210 degrees. And then you read the question. Are you gonna tell me we're not quite done?
I thought cosine was 160.
Oh Lord, you're right. I'm wrong. Back the pony up. We did sine. We did sine. That's cosine. What does cosine give me 1/2?
Cosine. Oh yeah. I'm sorry. 60. Yeah.
So this would be 60 and 60, which gives me, back this up, 120 and 240, right? Okay. Now pausing there.
And
Read the instructions again.
it said all real values of x.
All real values. That means all of them. So we got to add 3 sig. We got to keep adding 360s, right? Because it works for every single one for the rest of the eternity. How am I going to write that?
You put where n
There you go.
equals dot dot dot.
X equals 120 degrees plus, repeats every,
2. Wait.
well, for degrees it would be
360.
360 degrees.
Oh.
And I write the word and. Or you have to use the proper and notation, which
So
none of you know. So don't use anything other than writing the word and. And then
240.
240 degrees plus 360 degrees n, where
Or,
n is equal to.
-1. Well, dot dot dot. -1, 0 or 1 dot dot dot.
And that would be a complete list of all the places where x would solve this solution. Ain't that fun? Not fun? Gotta be fun. All right, 8, 9, 10 are waiting for you. A warning on 10. Think good algebra before you start changing the sines and cosines. You'll save yourself a lot of pain and suffering. A lot of pain and suffering. Just a warning. On number 10, if you change everything sine and cosines without thinking about it, instead of doing good algebra first, you might be really unhappy. You're going to make the problem 10 times longer.